Alright, this is problem number 138, where we're talking about parallel lines and transversals, right, with corresponding angles and alternate exterior angles and alternate interior angles and all that good stuff. So, based on the diagram below, which statement is true? So, what I typically do is I start solving for things that I know, right? This is 60, this is 60, this is 120, this is 60, this is 120, this is 120, 115, this would be 65, 65, 110, 70, and 70. So I've solved for every angle. Okay? Now look at this. You see how these two alternate interior angles and these two alternate interior angles are congruent? Since that's the case, that only happens when these two lines are parallel. So line D has to be parallel to line E. Okay? That's one of the ways you can tell, is for corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent. What are these? Corresponding interior angles, I think they're called. Let me see. Or same side interior angles are supplementary, right? Same side interior angles are supplementary. These two angles are supplementary. These two are supplementary. So there's a lot of ways that you can tell that these two lines are parallel. Okay? And that doesn't happen for any of these other lines. It only happens for line D and line E. So it's choice 4. Number 139. A transversal intersects two lines. Which condition would always make the two lines parallel? Alternate interior angles are congruent. Vertical angles doesn't always make the two lines parallel, right? Corresponding angles are supplementary. No, they have to be congruent. And same side interior angles are complementary. No, they'd have to be supplementary. So it's choice 2. In the diagram below, line P intersects line M and line N. If the measure of angle 1 is 7x, and the measure of angle 2 is 5x plus 30, lines M and N are parallel when x equals, well, those are alternate interior angles, and they have to be equal if those lines are parallel, so they have to be equal. So we're going to solve for x. When x equals 15. Okay? So we're on 141. Lines N and M are cut by transversals P and Q. What value of x would make lines N and M parallel? I just start solving for angles. If this is 80, this is 80 because of vertical angles. If this is 30, this is 30. These three are supplementary, right? So 80 and 30 is 110 plus another 70 would be 180. So this is 70 because of vertical angles. Now, what value of x would make lines N and M parallel? Well, alternate interior angles would have to be congruent. So this would have to be 70, right? Those are alternate interior angles. This angle would have to be, you see this? These are alternate interior angles too, but it's the combination of these two angles. So this would be 110, and then I can solve for the rest of these also, just like that. Okay? But x would have to be 70. I solved for more than I had to. Line N intersects lines L and M, forming the angle shown in the diagram below. Which value of x would prove that they're parallel? I think that's a 6x. 6x plus 42 equals 18x minus 12. Obviously, when the alternate interior angles are equal is when they would be parallel, so that's what I'm solving for. Minus 54, subtract 18x, negative 12x equals negative 54, divide by negative 12. x equals 4.5. And it says what value of x, so it would be 2. Okay, let's look at the next one. Okay, 2 lines cut by a transversal. It wants to know if the measure of angle 1 is 4x plus 14 and 2 is 8x plus 10, lines M and N are parallel when x equals. Well, this would have to be equal to angle 1, right? This would have to be equal to angle 2. This would be angle 1, angle 1, angle 2, angle 2. So they would have to be supplementary, right? So 4x plus 14 plus 8x plus 10 has to equal 180 if those lines are parallel. So we got 12x plus 24 equals 180 minus 24 from both sides. 12x equals 156 divided by 12. Choice 3. $144. Diagram below of a quadrilateral with a diagonal BD. The measure of angle A is 93. ADB is 43. Angle C is 3x plus 5. BDC is x plus 19 and BDC is x plus 19 and DBC is 2x plus 6. So everything is labeled. That's a 6 there. Okay. Determine if AB is parallel to DC and explain your reasoning. Okay. Well, let's see here. Okay, we can figure out this angle, right? Because we can do 180 minus 93 minus 43 44. And then if these lines are parallel, right? If these two lines are parallel, then the alternate interior angles would have to be equal. So that would be x plus 19 would have to equal 44. So x would be 25. So then this angle, x plus 19, would be 44. This angle here would be 56. And this angle here would be 80. So let's see if that works out. If 80 plus 56 plus 44 is 180, and it is. So when x equals 25, alternate interior angles are congruent, and triangle BCD has all angles adding up to 180. Okay? That's good enough. I mean, that's not perfect, but it's good enough. Let me just see if I could quickly look up what they put for that. Maybe there's a little bit something I can add. Let's see. General. This is this problem number 144. Let's see. No, that's fine, because alternate interior angles are congruent. That's it. That's exactly what they put. So let's see, 145. L is parallel to M and QR is perpendicular to ST at R. If the measure of angle 1 is 63, we know that this is 63 because alternate interior angles are equal. And this is 90. So 90 and 63, whoops, 90 plus 63 is 153, and then if we subtract that from 180, we get 27. So this is 27. That's it. That's the measure of angle 2. 27 degrees. And we should show a little work like 27 plus 90 plus 63 equals 180. That's all you need to show, though. 146, Pythagorean theorem time. The diagram below, BDA is 90. It has to be a right triangle in order to do Pythagorean theorem, remember? AD is 5, radical 2. AB is 2, radical 15. This one is x. So x squared plus 5 radical 2 squared equals 2 radical 15 squared. So x squared plus, this squared applies to both of those numbers, so it would be 25 times, when you do radical 2 squared, it gets rid of the radical, so it's just 25 times 2 equals 2 squared is 4 times radical 15 squared is just 15. So x squared plus 50 equals 60. Subtract 50. X squared equals 10. Take the square root of both sides. X equals the square root of 10. Choice 1. Diagram below is a pennant in the shape of an isosceles triangle. The equal sides each measure 13. The altitude is x plus 7 and the base is 2x. So we know that this is a right angle and so is this, and we also know that this is x and this is x if this whole thing is 2x. So now we have two right triangles, so we can find the length of the base. Right, let's just look at this first right triangle right here. I'm just going to redraw it. We have 13, we have x plus 7, and we have x. Let's solve that. X squared plus x plus 7 squared equals 13 squared. X squared plus x plus 7 times x plus 7 equals 169. X squared plus, we're doing FOIL now, right? X squared plus 7x plus 7x plus 49 equals 169. Okay? So we have 2x squared plus 14x plus 49 equals 169. Okay, let's keep going. We gotta solve this quadratic equation. So we gotta get the one side to equal 0. So 2x squared plus 14x minus 120 equals 0. Divide everything by 2. We get x squared plus 7x minus 60 equals 0. Now we got to do the double bubble thing to solve this. The factors of 60, of negative 60, that add up to positive 7 would be, let's think, 6 and 10, no, that's not going to do it. Why am I not seeing the... Did I do something wrong here? Because I usually can see these factors right away. Let's factor negative 60. Negative 1 and 60. 1 and negative 60, negative 2 and 30, 2 and negative 30, 3 and negative 20, negative 3 and 20, 4 and negative 15, negative 4 and 15. Let's see, 5. That's going to be it. 60 divided by 5 is 12. So we would have negative 5 and 12, 5 and negative 12. So which one adds up to positive 7? This one. So it's x minus 5, x plus 12. See how that works? Now we solve both of these, set them equal to 0. Add 5, x equals 5, subtract 12, x equals negative 12. But you can't have a negative length of a side, right? That doesn't make sense. You can't have a negative length of a side. You don't measure something and get a negative answer. So x has to be 5, but 2x equals 2 times 5 because they want the length of the base, which is 2x, equals 10. So that one, a lot of ways you can make a mistake on that one. I can't believe they actually gave this problem, but they did. As shown in the diagram below, a kite needs a vertical and a horizontal support bar attached at opposite corners. These are the bars. The upper edges of the kite are 7 inches. The side edges are x inches. And the vertical support bar is x plus 1 inches. What is the measure in inches of the vertical support bar? Alright, well, we know that there are 4 right angles here, right? So let's work with this triangle first. We know that x plus 1 squared, we don't know the base. Let me think about this one for a second. Alright, so we don't even need to know this fact here because look, we're looking at this triangle right here. Either one of them, it doesn't matter. This right angle actually applies to this whole triangle here. Okay, that right angle actually goes all the way to this side. Right here. Okay, at first, when I first looked at it, I thought that right angle was just for this piece, but that wouldn't even make sense, okay? So we're looking at this triangle right now. Okay, so we have x squared, or x plus 1 squared equals x squared plus 7 squared. So this is c squared equals a squared plus b squared, or you can reverse it. So we would have x plus 1 times x plus 1 equals x squared plus 49. So let's do FOIL. X squared plus x plus 1 equals x squared plus 49. Subtract x squared, that's nice, that makes the problem much easier. So we have 2x plus 1 equals 49, subtract 1, 2x equals 48, divide by 2, x equals 24. The vertical support bar is x plus 1 though. So x plus 1 equals 24 plus 1 equals 25. Of course 24 is a choice, and you know how many people put that. Don't make that mistake. Go back and read the problem 10 times if you have to. You have plenty of time for this test. There's no reason to make stupid mistakes. Which set of numbers does not represent the sides of a right triangle? Okay. Any two sides must be greater than the other. So, let's look at number 1. 6 plus 8 must be greater than 10. 8 plus 10 must be greater than 6. And 6 plus 10 must be greater than 8. This one says 14 is greater than 10. That checks. 18 is greater than 6. That checks. 16 is greater than 8. That one checks out. So we look at choice 2 because we're looking for the one that doesn't represent the sides of a triangle. 8 plus 15 must be greater than 17. 15 plus 17 must be greater than 8. And 8 plus 17 must be greater than 15. Well, this says that 23 is greater than 17. That works. 32 is greater than 8. That works. And 25 is greater than 15. That works. So we go to choice 3. 8 plus 24 must be greater than 25. 24 plus 25 must be greater than 8. And 8 plus 25 must be greater than 24. So this one is going to be 32 is greater than 25. That's true. 49 is greater than 8. That's true. And 33 is greater than 24. That's true. So we got one more to try, which should be the answer. So let's check. 15 plus 36 must be greater than 39. 36 plus 39 must be greater than 15. And 15 plus 39 must be greater than 36. Oh man, I totally messed this problem up. Yeah, I'm gonna need to erase all this. I'm doing a totally different problem. Because I could see right away that that one was going to work out too, so I was saying to myself, something must be wrong. So I think I need to slow down myself and read the question more than once. Alright, now look. It says, does not represent the sides of a right triangle. So that means that we got to test a squared plus b squared equals c squared for each one of these. So number 1, does 6 squared plus 8 squared equal 10 squared? Well, does 36 plus 64 equal 100? Yes, 100 equals 100, so that checks. Number 2, does 8 squared plus 15 squared equal 17 squared? 15 squared, I think it's 225, yep, so 64 plus 225, we want to know if that equals 289. 225 plus 64 is 289, so 289 equals 289. That one works. Then we have 8 squared plus 24 squared equals 25 squared. 64 plus 576 equals 625. 64 plus 576, 640 does not equal 625, so it's choice 3. Let's just double check. 15 squared plus 36 squared, and if you do 39 squared, you get the same thing, so that one works. So it's choice 3. Okay, 150. Julian or Julianne plans on drawing triangle ABC where the measure of A can range from 50 to 60 and the measure of B can range from 90 to 100. Given these conditions, what is the correct range of measures possible for angle C? So I'll draw 2 triangles. A, B, C, A, B, C. In this triangle, I'll put the lowest values. Angle A can range from 50, and in this triangle, I'll put the higher value to 60. Angle B can range from 90 to 100. So what can angle C range from? This would be 180 minus 90 is 90, 90 minus 50 is 40, and then we would have 180 minus 100 is 80, and 80 minus 60 is 20, so from 40 to 20. Choice 1. In an equilateral triangle, what is the difference between the sum of the exterior angles and the sum of the interior angles? Okay. All the interior angles are 60 degrees, and the exterior angles always add up to 180. I mean, it's always 360 for the exterior, and the interior is 180 for a triangle. So what is the difference between the sum of the exterior? So 360 minus 180 equals 180. Choice 1. Triangle ABC. Angle A is x, angle B is 2x plus 2, angle C is 3x plus 4. What is the value of x? Okay, so the sum of the measures of a triangle add up to 180, so that's what this is testing. X plus 2x plus 2 plus 3x plus 4 equals 180. X and 2x is 3x, plus 3x is 6x, plus 2 and 4 is 6, equals 180. Subtract 6. 6x equals 174, divide by 6, x equals 29. And it just says, what's the value of x? Okay, because it could ask you for one of the angles, and you'd have to plug it in. But this time it just wants x. DEF D is 3x plus 5, E is 4x minus 15, and F is 2x plus 10. Which statement is true? Well, I don't know because I got to figure out the angles first. So 4x minus 15 plus 3x plus 5 plus 2x plus 10 equals 180. 4x and 3x and 2x is 9x. Negative 15 plus 5 is negative 10. Plus 10 is 0, so equals 180. Divide by 9, x equals 20. So this angle would be 65. This one would be 80 minus 15 is 65. And this one would be 2 times 20 is 40 plus 10 is 50. Does that make sense? This would be a total of 130 plus 50 is 180. So what does we know? We know that angle E is equal to angle D, but that's not a choice, right? E is not equal to F, and D is not equal to F. But we also know that opposite sides, or sides that are across from angles that are equal, are equal. So EF equals DF. That would be choice 1. P, Q, R has angles in the ratio of 2 to 3 to 5. So P is 2x, Q is 3x, and R is 5x. What type of triangle is it? So We know that they add up to 180. Okay, so x is 18. So we have 36, 54, and 90. It's a right triangle. It's got a 90-degree angle. Okay? The angles of triangle ABC are in the ratio of 8x to 3x to 4x. What's the measure of the smallest angle? Well, 3x plus 4x plus 8x equals 180. That's 15x equals 180. X equals, I think that's 12. Let me just double check. 12. So 3 times 12 is 36. 4 times 12 is 48. And 8 times 12, pretty sure it's 96. So what's the smallest angle? Angle B, which is 36. Okay? In the diagram of JEA below, JEA is 90, JEA is 90, EAJ is 48, EAJ is 48. Line segment MS connects points M and S on the triangle such that the measure of angle EMS is 59. Okay? So what is JSM? They want to know this little angle here. Well, let's just start solving for angles. We can figure out this angle because in this big triangle, right, all 3 of these angles add up to 180. So we can do 180 minus 90 minus 48. This is 42. We also know that this angle, because it's just these 2 angles are supplementary, they form a linear pair. 180 minus 59 is 121. And now we can figure out the last angle in this little triangle. 180 minus 121 minus 42, 17. There it is, choice 4. Okay, we're going to do 2 more problems in this video. The degree measures of the angles of ABC are represented by x, 3x, and 5x minus 54. Find the value of x. You want like 10 of these problems. X plus 3x plus 5x minus 54 equals 180. 9x minus 54 equals 180. Plus 54. 9x equals 234. $26. That's it. Okay. One more for today. I think maybe we'll do more. Yeah, we might have to do a couple more. In right triangle in right triangle DEF, it says D is the right angle. So this is D, and then we have E and F. F is 12. Oh. F is 12 degrees less than twice E. So if E is X, F is 2X minus 12. Find the measure of angle E. Well, we know that these 2 have to add up to 90, right? So x plus 2x minus 12 equals 90. 3x minus 12 equals 90. Add 12. 3x equals 102. Divide by 3. X equals 34. And it wants E, which is X. So angle E equals X equals 34 degrees. Okay? Let me just see something. Yeah, let's go back one problem and say 26. Oh no, it just wants X, so we really don't want to call that a degree symbol. This one we do because it wanted the angle, degrees. Let's keep going. 159. In the diagram of triangle ABC below, AB is congruent to AC. The measure of angle B is 40. So then we also know that the measure of angle C is 40, and we know that this one is 100 because congruent sides are across from congruent angles. So angle A is 100. Triangle ABC. ABC. AB is congruent to BC. An altitude is drawn from B to AC and intersects AC at D. Which conclusion is not always true? Okay. Is not always true. ABD is congruent to CBD. BDA is congruent to BDC. Well, we know this one is always true because this has to be an altitude forms a 90-degree angle. AD is congruent to BD. That one we don't know is true, right? We know this one is true, but we don't know that this one is true. And AD is congruent to DC. We know that that's going to be true. So it's choice 3. Obviously, this and this could be different sizes, right? That's very easy to imagine. An isosceles triangle. AB equals BC, so this has to be A, B, C. Which statement will always be true? Well, we know that angle C will equal angle A, right? Angles across from congruent sides are congruent. Base angles of an isosceles triangle are congruent. So that's choice 3. Alright, so think about two isosceles triangles. Now, let's say the vertex angle is 50, right? Well, the base angles have to be congruent, so these must each be 65. And therefore these must also be 65, right? So if you know the vertex angle of isosceles triangles are congruent, then the two triangles are congruent. It's choice 2. Okay, I lied. The triangles must be similar, all right? Because angle, angle, angle only proves similarity, because this triangle could be bigger and the angles could still be 50, 65, 65. Okay, but because that only tells you the angle measure, it doesn't tell you the length of these sides. So that would have to be similar instead of congruent. And that's, let me see, 162 is 4. Okay? (163) in the diagram below, LMO is isosceles with LO equal to MO. LO is equal to MO. So that means that this angle and this angle are the same, so this has to be 55. This must be the difference from 180 plus these two. So 180 minus 110 is 70. This one we also know it's 125 because these two have to be add up to 180. And then finally, this little triangle here, 180 minus 125 minus, that looks like a 28, is 27. That's what angle N is. Okay? '64. AB is congruent to AC, so that means this is also x plus 20 because of that rule. The measure of angle A is 3x, x plus 20. What's the value of x? Well, we know 3x plus x plus 20 plus x plus 20 equals 180, right? So 5x plus 40 is 180. 5x equals 140. That should be, whoops, 5 into 140, 28. It says, what is the value of x? X is 28. Couple more. Point B is on AC such that ADB is an equilateral triangle. So this is equal to this is equal to this. And this is 60 degrees, and this is 60 degrees, and this is 60 degrees, which means that this is 120 degrees. That is up. Yeah, I think that's all I know so far. And DBC is isosceles with DB congruent to BC, so this is also congruent. So then 180 minus 120 is 60, but that has to be divided evenly amongst those two angles because those two angles are congruent. So it has to be 30 and 30. So what's the measure of angle C? 30 degrees. Two more. An RST. RS and ST are congruent. And RST is 46. Find the measure of STR. So again, this is the isosceles triangle, one of the theorems for isosceles triangles. 180 minus 46 is 134. Divide that by 2, 67. So the measure of angle STR equals 67 degrees. Last one for this video. The diagram below of GJK, H is a point on GJ. HJ is congruent to JK. HJ and JK are congruent. So I can figure out these two angles because they're going to be equal. So 180 minus 70 divided by 2 is 55. This is 125. And this guy's 28, so now I can figure out that one. 180 minus 125 minus 28 is 27. So I figured out everything I need to know. Determine whether GHK is an isosceles triangle and justify your answer. No. Because triangle GHK has 3 different angles. Okay? And I showed all the angles here, so that's it. An isosceles triangle has to have 2 of the same angle. And that's it for this video.